we are doing the chapter capital budgeting, in which Hiller's model was discussed. One more problem we'll be doing in the Hiller's model, that is question number 41. 42 I'll give it as homework. It is a subset of question number 43. We'll read the question and you will be convinced that you should be able to do it. So 42 I'll be giving it as homework. Once I complete the question number 41 and Hiller's model, a small problem involving certainty equivalent approach will be done by us, and one problem in which NPV will be calculated with some data given and probability is given will be doing in the next stage, where uniform cash flows will be involved. Once we complete these three sums in today's class, we'll start with the next chapter called as options in the segment called as derivatives. So we are doing the area Hiller's model in the capital budgeting concepts. See. Let us summarize what was done in the Hiller's model and do one more problem in that regard and then go for the next area. Okay, see. In Hiller's model, we saw that first we have to calculate the expected net present value using risk-free rate. We all remember or not? First we have to find out the expected NPV using risk-free rate. Expected NPV is the average NPV or the mean NPV. So there can be a standard deviation around the expected NPV. How the standard deviation should be calculated is the main discussion in the Hiller's model, where Hiller classifies the project into two types: project whose cash flows are dependent over time and project whose cash flows are independent over time. Those projects whose cash flows are dependent over time means what happens in the first year, that trend will be followed in what the subsequent years. First year it is a best cash flow means all the years will be having what? First year situation is worst means all years will be what? Worst and so on. So this is what we call as correlated over time or dependent over time. In case of independent cash flow, what happens in the first year has got no relevance to what is going to happen in the second year. First year can be best, but second year can be what? Worst also. Third year can be moderate and so on. So every year what is going to happen is purely independent of what has happened in the previous year. In this case, cash flows are said to be what? Independent or uncorrelated. Right or not? No. The probability of a best cash flow in case of correlated cash flows is, what is the probability of that cash flow in the first year? First year probability is what? The probability. But in case of independent cash flow, if they ask you what is the best case NPV means, it should be best in all the years. It becomes what probability? Joint probability. Is the next issue we have discussed. Third is how to calculate standard deviations of the NPV. Very simple. Find out the standard deviation of every year cash flow. Once you find out the standard deviation of every year cash flow, discount the standard deviation, that we call as discounted standard deviation. Discounted standard deviation is the standard deviation of NPV if the cash flows are dependent. If the cash flows are independent, what you do is square the discounted standard deviation and then take the square root. In that case, we'll be getting the standard deviation of NPV if the cash flows are independent over time. Able to recollect or not? Okay. Now, in such a situation, once we find out the net present value, we calculate something called as coefficient of variation. What is the formula for coefficient of variation? Standard deviation divided by mean is the coefficient of variation. Once we find out the coefficient of variation, then we identify the discount rate. Every company will be having a discount rate schedule. Okay. So they say for coefficient of variation of less than 0.8, use 9% discount rate. 0.8 to 1, use 10%. Above 1, use 12% and so on. They will be having a table of the discount rate for different coefficient of variation. Based on the project's risk or coefficient of variation, they select the appropriate discount rate. Such adjusted discount rate selected. We call it as what? Risk adjusted discount rate, and then find out the NPV. This NPV we call as a risk adjusted NPV, and this is what has been discussed in the Hiller's model till now. Response is or no? No. I'll give you the notes for this. I have to give the typed notes. I did not dictate the notes. Just to save time, I'll give you the printed notes for the Hiller's model in the next class. Okay. Now, one more problem let us do in the Hiller's model to get the grip over it. Once we complete it, we can just go for the two small slots and then start with the derivatives. Okay. Now, okay. Take question number 41. Take question number 41. Take question number 41. Skylark Airways is planning to acquire light commercial aircraft for flying class clients at an investment of rupees 50 lakhs. Page number 67, question number 41. The expected cash flow after tax for the next 3 years are as follows. Year 1, cash flow after tax 14 lakhs, or it may be 18 lakhs, 25 lakhs, 40 lakhs. Probabilities are given. Year 2 also cash flow can be 15, 20, 32 and then 45. Probabilities are given. Year 3 it is 18, 25, 35 and then 48. Probabilities are given. Company wishes to take into consideration all possible risk factors relating to the airline operation. The company wants to know expected NPV of this venture at a risk-free rate of 6%. In the original Hiller's model, I first calculate the mean NPV at what rate? Risk-free rate. Then only I have to identify the discount rate after finding out the standard deviation. Response is or no? No. Next is standard deviation from the expected NPV, assuming that cash flows are independent over time and B, cash flows are dependent over time. If cash flows are independent over time, what is standard deviation? Discount the standard deviation square root. And if they are dependent over time, what is standard deviation? Discount the standard deviation. Response is or no? No. Next is, what is the probability of best case NPV and the worst case NPV in both the cases? That's a question which has been given. Everybody, can we start or not? No. Just 1 minute time I'll give you. Go through the question before I start with the solution. Please. Output சரியில்லைப்பா. டிவி ஸ்க்ரீனில் அவுட்புட் சரியில்லை. Shall I start or not? No. See, first question is to find out what? Expected NPV. What you should do? Find out expected cash flow for year 1. Find out expected cash flow for year 2. Expected cash flow for year 3. And then discount the expected cash flow using what rate? 6% risk-free rate. I'll be getting the expected NPV. First point, everybody yes or no? No. First year the expected cash flow is 14 lakhs or 14 lakhs average. Simple or weighted average? Weighted average. Weights are what? Probabilities. Can do it together or not? Let's do the solution together. Write down first. Step 1. Expected cash flow year 1. Step 1. Expected cash flow year 1. Expected cash flow year 1. Can we start now? Now. Cash flow, probability, expected cash flow. Cash flow, probability and then expected cash flow. Let's do it together. cash flow probability, and then expected cash flow. Okay, first, what all the cash flows for year 1? It may be 14 lakhs, or maybe 18 lakhs, or 25 lakhs, or 40 lakhs. 14, 18, 25 and 40. What are the probabilities of these cash flows here? 0.1, 0.2, 0.4, 0.3. 0.1, 0.2, 0.4 and 0.3. What is the expected cash flow? 1.4 lakhs, 3.6 lakhs, 10 lakhs, and then 12 lakhs. 1.4, 3.6, 10 lakhs, and then 12 lakhs. Now, if I total, what the total expected cash flow it is? 27 lakhs. The expected cash flow is 27 lakhs. The expected cash flow is 27 lakhs. Everybody, yes or no? Now, first year I expect my cash flow to be how much rupees? 27 lakhs. Step 2, expected cash flow year 2. Step 2, expected cash flow year 2. Cash flow probability, expected cash flow. Cash flow probability, and then expected cash flow. Okay. What are the possible year 2 cash flow? Can be 15 lakhs, 20 lakhs, 32 lakhs, 45 lakhs. Probability is 0.1, 0.3, 0.4, 0.2. 0.1, 0.3, 0.4 and then 0.2. The expected cash flow is 15 lakhs into 0.1, 1.5 lakhs. 20 lakhs into 0.3, 6 lakhs. 32 lakhs into 0.4 gives you 12.8 lakhs. 45 lakhs into 0.2 gives you 9 lakhs. 45 lakhs into 0.2 gives you 9 lakhs. If I total, the expected cash flow for year 2 is 29.3 lakhs. Year 2 expected cash flow is 29.3 lakhs. Yes or no? No. Next. Finish copying up. Step 3. Expected cash flow year 3. Expected cash flow year 3. Expected cash flow year 3. Cash flow probability, expected cash flow. Cash flow probability, and then expected cash flow. What are the year 3 cash flows? 18 lakhs, 25 lakhs, 35 lakhs, 48 lakhs. 18 lakhs, 25 lakhs, 35 lakhs, and then 48 lakhs. Tell me their probabilities. 0.2, 0.5, 0.2, 0.1. The expected cash flow is 3.6 lakhs, 12.5 lakhs, 7 lakhs, 4.8 lakhs. 3.6 lakhs, 12.5 lakhs, 7 lakhs, and then 4.8 lakhs. What are the expected year 3 cash flow? 27.9 lakhs. Year 3 cash flow expected is 27.9 lakhs. Now, first what we have done here, we found out the expected cash flow for year 1, year 2, and then what? Year 3. Once I know the expected cash flow, next I have to calculate what? Expected NPV. Can we start or not? Now, next step 4, expected NPV. Step 4, expected NPV. Expected net present value. Here, cash flow, present value factor at what percent? 6% is what? High risk, average risk, no risk, no risk. I should not bring in risk unless I find out the standard deviation. Yes or no? Now, the original Hiller's model, discount what rate? Risk-free rate. PVF at 6%, present value factor at 6%, and then discounted cash flow. PVF at 6% and then discounted cash flow. Now, 1, 2, and then 3 years. We have 3 years. Just now we found out in first step, second step, and third step the expected cash flow. Na? Please tell me the expected cash flow. 27 lakhs. First year 27 lakhs. Second year 29.3 lakhs. 27 lakhs, 29.3 lakhs. Third year 27.9 lakhs. 27 lakhs, 29.3 lakhs, 27.9 lakhs. Present value factor at 6%. 1 divided by 1.06. Tell me what is the factor? 0.9434. The factor is 0.9434 is equal to 0.8900. 0.8900 is equal to 0.8396 is equal to 0.8396. Discounted cash flow, 27 lakhs into 0.9434 gives you 25.47 lakhs. 25.41 lakhs. 29.3 lakhs into 0.8900 gives you 26.07 lakhs. 26.07 lakhs. 27.9 into 0.8396 gives you 23.43 lakhs. 23.43 lakhs. If I total, tell me what is the expected, I think all writing along with me or not? Is the speed okay or not? No. Expected NPV or discounted cash flow. Sorry, what is discounted cash flow? 74.97 lakhs. The discounted cash flow is 74.97 lakhs. Look at the workbook. What is the initial investment in the project? Look at the first line. What is the investment here? 50 lakhs. The airline invested 50 lakhs in this project. Now, what is the expected net present value? It is 24.97 lakhs. Expected NPV is 24.97 lakhs. Expected NPV is 24.97 lakhs. NPV positive project can be accepted. Yes or no? This cannot be believed as NPV because discounted risk-free rate. Yes or no? Most of the project at risk-free rate will be giving only acceptance only. Right or not? No. I have not yet incorporated what? Risk. Then only that NPV can be what? Seen. Always adjusted NPV only or a risk-adjusted NPV only should be believed, not a risk-free rate NPV. Are you following or not? No. This is only a starting point to identify the discount rate. Everybody following or not? No. Tell me, 24.97 is exact NPV or mean NPV? Always it will be 24.97. Can deviate? Can deviate. Every year cash flows are what? Deviating. NPV also can what? Deviate. There is only a mean NPV. Yes or no? Whenever we have a mean, the mean should be having what? Standard deviation. This NPV should be having a standard deviation or not? Yes. Tell me how to find out the standard deviation of this NPV. First step is to find out what? Standard deviation of the every year cash flow. Remember? First year we have an expected cash flow 27 lakh. Second year expected cash flow 29 point something. Third year 27 point something. Yes or no? No. These are all expected cash flow. These cash flows will deviate or not. First step is to find out what? Standard deviation of the cash flow. Point number 1. Yes or no? Once you find the standard deviation of the cash flow, next what do you do? Discount it. Yes or no? We'll be getting what? Discounted standard deviation. The discounted standard deviation is what? Standard deviation of the NPV. If the project's cash flows are what? Correlated or dependent over time. If they are independent, what do you do? The discounted standard deviation, please what you will do? Square it and then take the square root. I'll be getting the standard deviation of the NPV. Right or not? Yes or no? Can I proceed further? Now, write down next step. If you are away, next step what I am going to do is what? Standard deviation of 27 lakhs. Next step, standard deviation of 29.3 lakhs. Next step, standard deviation of 27.9 lakhs. And the next step is what? Standard deviation of the net present value. Or you have the full clarity or not? No. It's a very important concept, very regularly asked in the exams. Can I proceed or not? Now, next step. Step 4 or step 5? Step 5. Calculation of sigma and sigma square. Sigma square means what? Variance. Okay, standard deviation and variance. Calculation of standard deviation and variance of annual cash flows. Calculation of standard deviation, variance of annual cash flow. Calculation of standard deviation and variance of annual cash flow. Now, can I start or not? Now, first. Year 1 cash flow. Underline that. Year 1 cash flow, underline that. So, before that, tell me what is the formula for standard deviation? Square root of sigma p into x minus x bar the whole square. Now, with probability, we discuss in the portfolio theory or not? Same formula, okay? Now, probability, first column probability, guess pannappa, second column is what? Cash flow, third column is what? Cash flow minus cash flow bar, that is cash flow minus average cash flow, third column. Fourth column is what? P into cash flow minus cash flow bar the whole square. P into cash flow minus cash flow bar the whole square. I think you are able to understand or not? No. Tell me what are all the probabilities for the first year. Tell me what the probability is. It is what? 0.1, 0.2, 0.4, 0.3. 0.1, 0.2, 0.4 and 0.3. Look at the workbook. Please tell me the cash flow for the first year. It may be 14 lakhs, maybe 18, 25 lakhs, 40 lakhs. 14, 18, 25 and 40 lakhs. Now, look at the notebook. First step, can you tell me what is the expected cash flow for year 1? You have how much it is? 27 lakhs. Average cash flow is 27 lakhs. X minus X bar. 14 lakhs minus what? 27 lakhs. Are you understanding writing or not? What is the number here? Minus 13 lakhs. 14 lakhs minus 27 lakhs is minus 13 lakhs. 18 lakhs minus 27 lakhs minus 9 lakhs. 25 lakhs minus 27 lakhs minus 2 lakhs. 40 lakhs minus 27 lakhs 13 lakhs. 13 lakhs, 9 lakhs, 2 lakhs and 13 lakhs. First 3 are negative, next is what? Positive. Okay. Now, when you multiply P into, very simple, 0.1 into 13 lakhs into 13 lakhs. Are you following or not? 0.1 into 13 lakhs into 13 lakhs. I get a number is 16 lakh 90,000 lakhs. அதுக்கப்புறம் 5 0 வரும். 16 lakh 90,000 followed by what? 5 zeros. என்ன புரிஞ்சுதா? நீ போட்ட வரும் என் கால்குலேட்டர்ல 16 lakh 90,000 lakhs. Okay. 16 lakh 90,000 lakhs. The number will be followed by what? 5 more zeros. Everybody following, huh? No. Next is 0.2 into 9 lakhs into 9 lakhs. 0.2 into 9 lakhs. 9 lakhs. Guess how much it is? 16 lakh 20,000 lakhs. I did not have the space here. I put lakhs. That means the 16 lakh 90,000 should be followed by how many zeros? 5 more zeros. என்னப்பா ஞாபகம் இருக்கா? நிறைய zero இருக்கு here. Don't miss a zero. 16 lakh 20,000 lakhs. Now, 0.4 into 2 lakhs into 2 lakhs. Yes or no? That gives you 1 lakh 60,000 lakhs. 1 lakh 60,000 lakhs. 1 lakh 60,000 lakhs. 0.3 into 13 lakhs into 13 lakh gives you 50 lakh 70,000 lakhs. 50 lakh 70,000 lakhs. 50 lakh 70,000 lakhs. Everybody, are you understanding it or not? No. If a total, I'll be getting the variance. Yes or no? The variance is 85 lakhs 40,000 lakhs. 85 lakhs 40,000 lakhs. 85 lakhs 40,000 lakhs. One thing I say, when you take square root, etc., you should write the full number and take what? Square root. If you take in multiples of thousands and all, mistake may arise. I'm saying only for your safety. Okay. Now, you have to take the full number. 85 lakhs 40,000 0000 followed by what? 50 and then plus the square root. I'll be getting, how much going to be? 9 lakh 24,000 or rounded off here 9.24 lakhs. That means what? 9 lakh 24,000. The standard deviation is 9 lakh 24,000 or 9.24 lakhs. Everybody, yes or no? Now, don't take square root as 85 lakh 40,000 square root. It may come, may not come because zeros matter in what? Taking square root. Write the full number and then take the square root because examination, when you know the concept, these mistakes may cost you marks. Are you following what I am saying? Now, this is going to be the first year standard deviation. Tell me, what is the first year expected cash flow? So first year what is expected cash flow? 27 lakh. Is that sure? No. It may what? Deviate. By how much? 9 lakh 24,000. Everybody, yes or no? Now, next. Year 2 cash flow. Year 2 cash flow. Year 2 cash flow. Same way understood it. Probability, cash flow minus cash flow bar. Probability into cash flow minus cash flow bar the whole square. Probability, cash flow minus average cash flow, probability into cash flow minus average cash flow the whole square. Can we start or not? I will open the columns up. Now, tell me what are the probabilities? 0.1, 0.3, 0.4, 0.2. 0.1, 0.3, 0.4 and then 0.2. Tell me what are all the cash flows every year? 15 lakhs, 20 lakhs, 32 lakhs, 45 lakhs, 15 lakhs, 20 lakhs, 32 lakhs, and then 45 lakhs. Take the calculator. Tell me what is the average cash flow. Tell me what is the average cash flow? 29.3 lakhs. Okay, 15 minus 29.3 lakhs. Look my number, 14.3 lakhs. The difference is 14.3 lakhs. 20 minus 29.3 lakhs minus 9.3 lakhs. 32 minus 29.3 lakhs, 2.7 lakhs. 45 minus 29.3 lakhs, 15.7 lakhs. 15.7 lakhs. 0.1 into 14 lakh 30,000 into 14 lakh 30,000. Are you following not? So 0.1 into 14 lakh 30,000 into 14 lakh 30,000. If I multiply, I'll be getting 20 lakh 44,900 lakhs. Did you understand the number or not? So 20 lakh 44,900 followed by how many zeros? 5 zeros. Lakhs. Are you following up? Now. Next. 0.3 into 9.3 lakhs into 9.3 lakhs. 0.3 into 9 lakh 30,000 into 9 lakh 30,000. That gives you 25 lakhs 94,700 lakhs. 25 lakh 94,700 lakhs. 25 lakhs 94,700 lakhs. Can I proceed above? Now. Third is 0.4 into 2 lakh 70,000 into 2 lakh 70,000. It will be giving me 2 lakh 91,600 lakhs. 2 lakh 91,600 lakhs. 2 lakh 91,600 lakhs. 0.2 into 15 lakh 70,000 into 15 lakh 70,000 gives me a number 49 lakh 29,800 lakhs. 49 lakh 29,800 lakhs. 49 lakh 29,800 lakhs. I hope the speed, are you all comfortable or not? Yes or no? Now, tell me the total is called as what? Tell me the name. Variance. The total is called as variance. The variance is 98 lakh 61,000 lakhs. 98 lakh 61,000 lakhs. Can take square root of 98 lakh 61,000 now? No. Take square root of what? 98 lakh 61,000 followed by 5 zeros. Are you following what I am saying? Now, standard deviation is equal to square root of 98 lakh 61,000 lakhs. Square root of 98 lakh 61,000 lakhs. Tell me how much standard deviation? 9.93 lakhs or 9 lakh 93,000 is the standard deviation. 9.93 lakhs. Standard deviation is 9.93 lakhs. Everybody, are you comfortable or not? Please tell me yes or no. Now, next, year 2 over. Next is what? Year 3 cash flow. Next is going to be year 3 cash flow. Shall I proceed? Now. First of all, up to year 2, have you all finished writing up? Now, let's go to year 3 cash flow. Year 3 cash flow. Probability, cash flow minus cash flow bar, and probability into cash flow minus cash flow bar the whole square. Probability, cash flow minus cash flow bar, probability into cash flow minus cash flow bar the whole square. Can I start or not? Now, what are the probabilities of each and every year? 0.2, 0.5, 0.2, 0.1. 0.2, 0.5, 0.2 and then 0.1. What is the cash flow? 18 lakhs, 25 lakhs, 35 lakhs, 48 lakhs. 18 lakhs, 25 lakhs, 35 lakhs and then 48 lakhs. Please, all of you tell me, what is the mean cash flow for the year 3? 27.9 lakhs. Okay. 18 lakhs minus 27.9 lakhs is going to give you how much here? Minus 9.9 lakhs. That gives you minus 9.9 lakhs. 25 minus 27.9 lakhs gives you minus 2.9 lakhs. 35 minus 27.9 lakh gives you 7.1 lakh. 48 lakhs minus 27.9 lakhs gives you 20.1 lakh. That gives you 20.1 lakh. Shall I proceed up? Next. Probability into cash flow minus cash flow bar the whole square. 0.2 into 9.9 lakhs into 9.9 lakhs. Tell me the number is 19,60,200 lakhs. 19,60,200 lakhs. 0.5 into 2,90,000 into 2,90,000. 0.5, what is the number here? It is 4,20,500 lakhs. 4,20,500 lakhs. 4,20,500 lakhs. 0.2 into 7,10,000 into 7,10,000. What is the number? 10 lakh 8,200 lakhs. 10 lakh 8,200 lakhs. 10 lakhs 8,200 lakhs. 0.1 into 20.1 lakh into 20.1 lakhs. If you multiply, what the number here? It is 40 lakh 40,100 lakhs. 40 lakhs 40,100 lakhs. 40 lakhs 40,100 lakhs. Can you see? If I total, the variance is, how much here the variance is? 74 lakh 29,000 lakhs. The variance is 74 lakhs 29,000 lakhs. 74 lakh 29,000 lakhs. Everybody, yes or no? No. Standard deviation. Square root of 74 lakh 29,000 lakhs. Standard deviation is square root of 74 lakh 29,000 lakhs. How much going to be the number here? 8.62 lakhs. Huh? So 8.62 lakhs or 8 lakh 62,000. 8.62 lakhs or 8 lakh 62,000. Now, what we have done, calculation may be big, yeah, the matter is small. What we have done, found out the standard deviation for each and every year cash flow, right or not? Now, next is, look at the question. What is part A question? Expected NPV of the venture, are you with me or not? Expected NPV of the venture at the risk-free rate of 6%. Did you find out the expected NPV or not? Yes. What was the expected NPV answer? How much going to be? 24.97 lakhs is the expected NPV. Yes or no? Now, next is standard deviation from the expected NPV, assuming that cash flows are independent and cash flows are dependent. Cash flow dependent. Tell me the answer. One word. Discounted standard deviation. Cash flows are independent. What is the answer? Discounted standard deviation square. Take what? Square root. Everybody, yes or no? Now, can you start doing the next calculation? Write down. Next. Step number 3 or 4 up. Step number 6. Okay. Take step number 6. Calculation of standard deviation of NPV. Step 6. Calculation of standard deviation of NPV. Calculation of standard deviation of NPV. Okay. Can we start or not? Now, have the following columns. First column is year. First column year. Second column is what? That is cash flow, standard deviation. Standard deviation of the cash flow. Yes or no? No. The third column is what? Present value factor at what rate? 6%. You know, for finding out risk, you should not use a risky rate. Yes or no? None. Next is what? Discounted standard deviation. Next is what? Discounted standard deviation squared. Enappa right or not? No. This is for finding out for dependent. That is for finding out for what? Independent. Enappa right or no? Tell me. Okay. Year what? 1, 2 and then 3. 3 years cash flows. First year cash flow, what is standard deviation you found out? Tell me. 9,24,000. 9,24,000. Write the numbers in full. Second year 9,93,000. 9,93,000. Third year 8,62,000. 8,62,000. Present value factor. Tell me 6% what the factor? 1% point? 9434. Second year? Point? 8900. Third year? 0.8? 0.8396. This is the present value factor at 6% for 3 years. Respond yes or no. Now, next is find out the discount the standard deviation. Standard deviation into what? PVF. 0.9434 into 9,24,000. I want a number. 1% here? 8,71,000. Berapa? 702, 8,71,000, 702. Next year. 8 lakhs? 7? 70, 770. Next. 7 lakh? 23, 22,000. Number 7 lakh 22,000. 735. This is 7 lakh 22,000. Correct or not? Any other number your choice. 735. 7 lakh 23,000. 735. Accept or not? No. What is total this? Tell me the total. 1 person சொல்லுப்பா. 207. 24,79,207. Is that discount the standard deviation? Yes or no? No. What is this? Yeah, standard deviation of the NPV if the cash flows are what? Dependent over time. Ennappa right or not? No. I don't want to do any experimentation. Can you square it off and add it? They square root or not? Can you do it or not? ரொம்ப simply square this number to get DSD square and then take what? Square root. I'll be getting the answer. Right or not? No. For you will be telling something, I'll be writing something. Can I proceed? No. Write down. I think I'll give this as homework. Yeah, can you do it? Okay, write down. Next. Write down. If the cash flows are dependent over time, if the cash flows are dependent over time, that is correlated, if the cash flows are dependent over time, that is correlated, if the cash flows are dependent over time, that is correlated, then the standard deviation of the NPV is, then the standard deviation of NPV is the discounted standard deviation. The standard deviation of NPV is the discounted standard deviation is equal to how much? 24,79,207. 24,79,207. Next paragraph. If the cash flows are uncorrelated, if the cash flows are uncorrelated, that is independent over time. If the cash flows are uncorrelated, that is independent over time. If the cash flows are uncorrelated, that is independent over time, then the standard deviation of NPV is equal to, then the standard deviation of NPV is equal to square root of, please fill in the blank, square root of what? Discounted standard deviation square. The standard deviation of NPV is equal to square root of discounted standard deviation square. Square root of discounted standard deviation square. Which is equal to, you fill in the blank later. Can you just do it and then have it or not? So I'll just give it as homework. Up to this, are you following or not? No. Square root of DST square. With this, we answer the second part of the question. Please respond yes or no. No. Next. Go to the part 3 of this question. Part C, please. Stop talking. Part C. What is the probability of best case NPV and worst case NPV in both the cases? What do you mean by both the cases? And what about cash flows are dependent over time, cash flows are independent over time. Okay, now best case NPV will occur. They don't ask you to calculate only probability. I said no. Best case NPV will occur. When we will get best case NPV? When first year is 40 lakhs, second year is what? 45, and third year is what? 48 lakhs. When all the three happen, I will be getting what? Best case NPV. Yes or no? When I will be having the worst case NPV? First year 14 lakhs, second year 15 lakhs, and third year what? 18 lakhs. Everybody understanding it or not? No. First of all, when the cash flows are dependent, when the cash flows are what? Dependent. What is the meaning of that? What happens in first year will happen in what? Subsequent year. If the first year best happens, now all year what? Best only happen. First year worst means what? All years worst will happen. Yes or no? No. In that case, the probability of best case NPV is what? First year probability. Yes or no? Tell me, what is the probability of best case NPV in first year? 0.3. So the probability of best case NPV when the cash flows are dependent is how much here? 0.3 or 30%. Accepted or not? Can I proceed further? Next. Suppose the cash flows are independent. Cash flows are what? Independent. To get the best NPV, how many things should happen? What are three things here? First year should be 40. Second year should be 45. Third year should be 48. Any one of the three, all the three. It is what? A joint probability. Tell me what is joint probability? 0.3 into 0.2 into 0.1. Response yes or no? This is not new, which we did in the decision tree problem already. Yes or no? No. So the probability of best case NPV is 0.3 into 0.2 into 0.1 when the cash flows are what? Independent over time. No. Now you answer without me explaining. Worst case NPV, dependent cash flow. What is the probability? 0.1. Yes or no? Worst case NPV, independent cash flow. 0.1 into 0.1 into 0.2 is the answer. Response yes or no? Ultimately ask you a question. Which project will be more riskier? Dependent cash flow project or independent? Dependent only more risky because entire project depends on what? First year. And if that is bad, everything goes what? Bad. But independent means what? They always have a chance to bounce back and then make it as a good project. Everybody yes or no? No. Write down. Let us write the answer for the next part. Step 5 or 6 or 7 or 8. Step number 7. Right? Step 7. Probability of best case NPV. Probability of best case NPV. Step 7 is probability of best case NPV. Okay. Branch it into 2. Branch it into 2. Branch it into 2. First branch is cash flows are dependent. Cash flows are dependent. Second branch is cash flows are independent. Cash flows are dependent. Second branch is cash flows are independent. Cash flows are dependent. Put a down here mark and write. What is the probability here? 0.3. Cash flows are dependent. The probability is what? 0.3. Written not? 0.3. Once again put the down here mark and write. Probability of the first year. Right? Probability of the first year. Cash flows are dependent. Now the probability is what? 0.3. Got about probability of first year. Go to the second branch. Cash flows are independent. Second branch, the cash flows are independent. Tell me, what the probability? 0.3 into 0.2 into 0.1. 0.3 into 0.2 into 0.1. 0.3 into 0.2 into 0.1. Tell me the number. 0.006. 0.006. The probability is 0.006. 0.006. Everybody understanding it or not? No. Next, last step. Step number 7 or 8? 8. Probability of worst case NPV. Probability of worst case NPV. Probability of worst case NPV. Branch it into 2. Branch it into 2. Cash flows dependent. Cash flows independent. Cash flows dependent. Cash flow independent. Cash flow dependent. Put a down here mark and write. What is the probability? 0.1. The probability is 0.1. Again put the down mark and write. What probability? First year probability. First year probability. Cash flows are independent. Second branch cash flows are independent. Put the down mark and write. Tell me what is the calculation? 0.1 into 0.1 into 0.2. 0.1 into 0.1 into 0.2. Tell me the number here. 0.002. 0.002. The probability is 0.002. 0.002. Everybody respond yes or no. Now, the question did not ask you to select the project. Now they given you the risk adjusted discount rate, details and all. What is asked has been what? Answered. Everybody respond. Are you all following the Hiller's model or not? Now, with this we complete the solution to question number 41. Okay, please. 42 is a examination problem only. but a much more simpler problem compared to the RTP. I'll just read the question and then give it as homework. Okay, see. XY Limited has, under its consideration, a project with an initial investment of rupees 1 lakh. 3 probable cash inflow scenarios with the probabilities of occurrence have been estimated as below. Cash inflow 20,000, 30,000, 40,000. Probability 0.1, 0.7 and then 0.2. The project life is 5 years and the desired rate of return is 20%. The estimated terminal value of the project assets under the 3 probability alternatives are 0, 20,000 and then 30,000. You are required to find the probable NPV. Probable NPV means what? Expected NPV. Find the worst case and best case NPV. State the probability of occurrence of the worst case if the cash flows are perfectly correlated over time. Very simple question. Not even ask you to find out standard deviation. Respond yes or no. Now, this question is very similar to question number 43 data wise, and they also not ask so elaborate question. They simply ask you to find out the best case, worst case and their probabilities. Everybody understood or not? Now, can I give question number 42 as homework or not? No. With this we complete Hiller's model, namely 41, 42 and then what? 43. Okay, now let us discuss one small concept called the certainty equivalent approach. Just a 5 minutes issue only and then we can just go on to the next chapter. Okay, now please. Okay. See, past 3 classes, what we are discussing? Tunga, what we are discussing? Capital budgeting under uncertainty. Capital budgeting under what? Uncertainty. Where emphasis is given more on risk angle. We analyze risk in so many angles. First we saw real options. How we can give me what? Expansion option as well as what? Abandonment. How with probabilities? One should draw a decision tree. We discuss in what? Next area. Risk is analyzed using the normal probability distribution. Risk you tackled using what? Simulation. We discussed the risk using what? Hiller's model. Then risk adjusted discounted approach and so on. Everywhere when I spoke in the last 3 classes, we are discussing about probabilities, discussing about what? Risk angle. We did not believe only discounted takes care of what? Risk. We had more discussion about what? Risk. How to eliminate it in the project evaluation was the main discussion. Respond is or no. No. The last approach here is called as what? Certainty equivalent approach. Okay. See, I'll read the question and then say what it is. Question number 31. Take question number 31. A company is examining 2 mutually exclusive investment proposals. The management of the company uses certainty equivalence to evaluate the investment proposal. From the following information pertaining to these projects, advise the company as to which project should be taken up. Year 0, investment is 25,000. 1, 2, 3 and 4, the cash flows are given. CE given. The word CE means certainty equivalent factor. You can also what certainty equivalent factor. 1, 0.8, 0.7, 0.6 and then what? 0.5. Similarly, if a project B also investment given and certainty equivalent factor is given. Firm's cost of capital is 12% and risk-free borrowing rate is 6%. This is all the details given. They also like whether I have to go for project A or project B is a question that is being asked. Okay. Just go through the facts of the question before I start with the solution. Shall we start up? Now, This is a very subjective method, nothing very scientific, but more judgmental, okay. Always one should not criticize judgmental. Sometimes judgments or instincts may be much more better than what a very scientific analysis of the situation. It is more judgmental, okay. Very simple, nothing great, no rocket science. Let us see what it means. Now, Project A, let us look at my words. Project A, year 1, what is the inflow? What is inflow here? 15,000. This is a certain inflow or uncertain? Government of India bond, the coupon will be certain, yes or no? It is not a Government of India bond. It is what? A project cash flow. It is what? Uncertain. Okay. Now, I asked the management, 15,000 you put as an uncertain cash flow. No. Tell me, what the certainty equivalent factor? He says what it is here? 0.8. Don't ask me how they say. It is based on the judgment of the business scenario. Or you'll find what I'm saying. People will have some instinct or they may having some reason to what? Believe it. So for this, we cannot have any scientific method. There's only management, what I'm saying, commitment which they take it. I found what I'm saying. Now, what is CE factor? 0.8. Can you tell me what is 0.8 into 15,000? So look, easy. What is 0.8 into 15,000? 12,000. Now, I can say like this. The uncertain cash flow is what? 15,000. It is as good as 12,000 certain cash flow. Are you following what I'm saying? I can say it is 15,000 uncertain cash flow or what? 12,000 certain cash flow. Something like equal units we did, right or not? So it is 15,000, 80% certain is as good as what? 12,000, 100% certain is some way of what? Saying it. I can say when I multiply a cash flow with certainty equivalent factor, I convert the uncertain cash flow into what? Certain cash flow. Response is so no. The management believes that surely it is worth how much? 12,000, 100% certainty. Are you following or not? No. See, as the year progresses in this problem, the factor what? Reduces, because in the later years, they cannot tell with what? So much assurance the cash flow. So the CE factor reduces as the year what? Increases. Now, when I multiply this cash flow with certainty equivalent factor, I get what cash flow? Certain cash flow. The certain cash flow should be discounted at 12% or 6% or 6%, because I have removed the risk by multiplying with what? Certainty equivalent factor. Now it is as good as what? Risk-free cash flow. Discount using what? Risk-free rate is what we call a certainty equivalence approach. This approach cannot be discussed in what? Classroom. Only the board of directors will be able to what? Convince the CFO about the certainty equivalent factors. So it is more judgmental rather than what? Statistical or scientific. I already said yes or no. It's a very subjective, what I say, way of understanding a project risk. But whatever subjective need not be pushed aside. Yes or no? Sometimes when I discuss about future, it may not be always possible to logically analyze. Sometimes it's possible to want to analyze more by instincts. That instinct only brings out the factor called the certainty equivalent factor. Decisions need not be always be objective. Can even be what? Subjective based on instinct. Are you following? I just want to convince you. Otherwise, you keep on saying, how is that certainty equivalent factor? How is it as 80%? I cannot say, you cannot say. Who can say? The board only, God the board only says, okay. God did not say these factors, okay. The board only said, it is up to them to justify it. Are you following or not? Now, can I start doing the solution? Rumba simple. Exam, when CE factor is given, multiply by what? Cash flow. They'll be getting what? Certain cash flow. They are given two interest rate. Why? They wanted you to use 12% because you can commit mistake. The real answer is what? 6%. And the two interest rates are given so that they have to select the appropriate rate at 6% for discounting it. Right or not? Now. Can I quickly complete the problem or not? Now. 5-minute solution. Can I start? Now. First. Certainty equivalence approach. Certainty equivalence approach. Project A. Okay, proposal A. Sorry, proposal A. Here, present value factor, cash flow, CE, risk-free cash flow, discounted cash flow. Here, present value factor, cash flow, CE, risk-free cash flow, and then discounted cash flow. Risk-free cash flow and then discounted cash flow. But can I start or not? No. Here 0, 1, 2, 3, 4. We'll add all the thing together, knock it out to find out NPV straight away, not to find out discount inflow and outflow. Year 0, 1, 2, 3 and 4. What the present value factor for year 0? 1. You should discount it using what rate? 6%. Take the calculator, 1 divided by 1.06 number here, 0.9434. Last problem also 6%, got about 0.9434. Next, 0.8900. 0.8900. Next, 0.8396. 0.8396. And then last, 0.7921. 0.7921. Tell me the cash flows of the project, please tell me the cash flow of the project. 15,000. So sorry, 25,000 minus 25,000. 15,000, 15,000, 15,000, 15,000. Minus 25,000, 15,000, 15,000, 15,000 and then 15,000. Can you proceed? Certainty equivalent factor. Today cash flow is 100% certain, yes or no? So what the factor it is? 1. 0.8, 0.7, 0.6, 0.5. 25,000 into 1 minus 25,000. 15,000 into 0.8, 12,000. 15,000 into 0.7, 10,500. 15,000 into 0.6, 9,000. Into 0.5, 7,500. Multiply the cash flow with the certainty equivalent factors. Discounted cash flow, 25,000 into 1, 25,000. Tell me, 12,000 into 1, 0.9434. What is the number here? 11,321. 11,321. 10,500 into 0.8900. Number is 9345. Number is 9345. 9,000 into 0.8396. Answer 7,556. 7,500 into 0.7921. 5,941. 5,941. 5,941. Now tell me, what is the net present value? 9163. 9163. How can I discount a project using risk-free rate? I have removed the risk, but multiply by what? Certainty equivalent factor. That's one issue. Are you following what I'm saying? So hence I discounted what rate here? Risk-free rate. Can I proceed or not? Next. Proposal B. Proposal B. Year present value factor. Year present value factor. Cash flow. CE. Risk-free cash flow, discounted cash flow. Here present value factor, cash flow, CE, risk-free cash flow and then discounted cash flow. Risk-free cash flow and then discounted cash flow. Can I start or not? No. Here 0, 1, 2, 3, 4. That is PV factor is 1. 1 by 1.06, 0.9434. 0.9434. Next number 0.8900. 0.8396. 0.7921. 0.8396. 0.7921. Cash flow given. What are the cash flows given? Minus 25,000. 9,000. 18,000. 12,000, 16,000. 9, 18, 12 and then 16,000. Certainty equivalent factor given as 1, 0.9, 0.8, 0.7, 0.4. 1.9, 0.8, 0.7 and then 0.4. Risk-free cash flow is cash flow into certainty equivalent factor. It is how much here? Minus 25,000. 9,000 into 0.9, 8,100. 18,000 into 0.8, 14,400. 12,000 into 0.7, 8,400. 16,000 into 0.4, 6,400. 6,400. 25,000 into 1, 25,000. 8,100 into 0.9434, 7642. 7642. 14,400 into 0.8900, 12,816. 12,816. 8,400 into 0.8396, 7,053. 7053. 6,400 into 0.7921, 5069. 5069. Knock it off. What is the net present value? 7580. 7580. Tell me, first or second or which is having highest in PV? Write down. Project A should be selected. Choose proposal A. Choose proposal A since it has the highest NPV. Choose proposal A since it has highest NPV. Choose proposal A since it has highest NPV. Since it has highest NPV. Stop writing and tell me, everybody having the full clarity or not? Okay. With this, we complete this concept called as certainty equivalent approach. Okay. All concepts we have completed in this chapter, capital budgeting. We have discussed for very long time the chapter capital budgeting without putting the banner as what? Capital budgeting. We discussed in the 3 slots. Okay. Learning objectives, please somebody give me. Now, just to have a consolidation, we did this chapter capital budgeting after the chapter portfolio was completed in 3 stages. Yes or no? Almost we did it for 2.5 weeks in how many stages here? 3 stages. First stage we discussed about leasing. We first discussed about what? Leasing. From lessor's angle, lessee's angle, we did all the leasing problems. Respond, yes or no? Lessor angle will be all about lease rental fixation. Lessee angle is borrow versus buy option. See, capital budgeting we discussed in 3 segments. One is what? Leasing. We discussed problem from lessor's angle as well as what? Lessee's angle. That's a very often repeated area in the examination. Very elaborately we did leasing, and at the end I gave you also a chart for selecting what? The discount rate for lessee's angle also. Once that is over, then we discuss about the capital budgeting concepts. We discuss the following concepts. Number 1, inflation and capital budgeting. Right or not? Number 2, overseas capital budgeting. Number 3 is the life disparity problem, EAB and EAC. Number 4 is timing disparity, modified NPV, modified IRR. Then we discuss about capital rationing, what to do with an idle fund. Number 6, we discuss about the sensitivity analysis. Number 7, we discuss about the abandonment problem. 8, we discuss about the long-term fund approach versus equity shareholders approach. 9, we discuss about base case NPV and adjusted NPV. All these issues we discuss in this particular first slot called as what? Capital budgeting concepts. Then we came to what? The third slot where we discuss the following. We discuss the risk-adjusted discounted approach. Now only discuss the certainty equivalent approach, normal distribution, simulation capital budgeting has been done, real option in capital budgeting has been done without derivatives, yes or no? And then decision making approach under capital budgeting using decision tree and Hiller's model are all the issues we covered in this chapter capital budgeting. If we total all the 3 segments, it is one of the big chapters in the syllabus, as big as a portfolio theory. Only thing is portfolio theory is more complex. This is what? Much more simpler. That's all. But this also is a very major chapter or a big chapter in which we have covered the 3 segments. Can I proceed?